Now see, first average acceleration. So average acceleration, that is change in velocity upon time interval. Okay. So delta V by delta T. So delta into Vxi plus Vyj, because V, that is Vxi plus Vyj upon delta T. So delta Vx upon delta T I caret plus delta Vy upon delta T j caret. Now average acceleration, that is, so here delta Vx by delta T will give you x component of acceleration. So Ax I caret delta Vy by delta T will give you y component of acceleration. So we can write now average acceleration A, that is Ax I caret plus Ay j caret. But here x and y components are average. Now same concept as we discussed in the previous theory. Instantaneous acceleration, that is limit delta t tends to 0, delta v by delta t, that is dv by dt, that is differentiation of velocity with respect to time t. So acceleration equal to limit delta t tends to 0, delta vx by delta t I caret plus limit delta t tends to 0, delta Vy by delta t j caret. So acceleration, that is dvx by dt I caret plus dvy by dt j caret. Clear? Now dvx by dt, differentiation of x component of velocity, that is x component of acceleration, differentiation of y component of velocity with respect to time t, that is y component of acceleration. So a equal to ax I caret plus ay j caret. Now magnitude of acceleration, that is under root ax square plus a y square, and its direction, that is theta equal to tan inverse y component upon x component. So in this way you can calculate your acceleration. Now see, mathematically as discussed here, we can say this thing, the direction of acceleration, that will be in the direction of change in velocity. So how one can find the direction of change in velocity? So say here, now in previous theory we already discussed this thing. If any particle is moving on the curved path, then at any point its instantaneous velocity is in tangential direction. Now see here, suppose we consider any particle which one is moving on this particular curved path like this. Then suppose at time t1 the particle is at position p. So its velocity at time t1 at position p, that is here in tangential direction. So v1, that is the velocity at some instant t1. Then after suppose particle change its position and reaches here, then its velocity again will be in this tangential direction. So now see here, we can observe this thing, the velocity vector is continuously changing one. Suppose at a particular instant t2, our particle is at position q. Then at q, its velocity that is again in the tangential direction. So here velocity vector v2 is prepared in tangential direction. Now we want to find change in velocity in this time interval t2 minus t1. So represent both the vectors from same origin. This is vector v1. So without changing the direction and magnitude, we can prepare here vector v1 that we already discussed in the summation of vectors. Then here prepare another vector which is in the direction of velocity v2 and having the same magnitude v2. So we can say this is vector v2. Now delta v, that is change in velocity, that is v2 minus v1. So that particular vector will be in this direction because we want v2 minus v1. So if we imagine the opposite vector of v1, then that opposite vector of v1 will be minus v1. So tail of minus v1 here and head of v2 will be here. So this vector joining to those two will give you the summation of v2 and minus v1. So that will give you v2 minus v1, and that is nothing but delta v. So see here, the direction of delta v, that is not the direction of v1, not the direction of v2, it is some third direction. Clear? So acceleration, that is in the direction of delta v. So in this way we can understand the direction of acceleration. But again here see, if we take time interval very small. હવે જો આપણે એક કામ કરીએ. Suppose this one is our velocity vector. ROA. બરોબર? આ રીતે આપણો velocity vector છે. Okay? Now suppose we displace this one like this. આમ કરીએ સહેજ. ખ્યાલ આવ્યો ને બેટા? અહીંથી સહેજ આમ ખસેડી દઈએ. એટલે મેગ્નિટ્યુડ ચેન્જ નથી કર્યો. Direction થોડીક ચેન્જ કરી. Right? But very small. So here what happens? Now if we prepare the vector joining to this two like this, then we can say if we move this one in this way, so here the head of this vector will form an arc, and very small arc. So if we join these two positions and prepare a vector like this, then that will be tangential to that arc. That will be tangential to arc. So delta v, if it is tangential to this arc, then we can say it is perpendicular to this radial vector. So in this case, acceleration will be perpendicular to velocity. Means if any particle is moving in a circular path like this, then its acceleration and velocity both are perpendicular to each other. Both are perpendicular to each other. Clear? ચાલો અહીં સુધી સમજ પડી બેટા બધાને? Example 4.4. The position of a particle is given by vector r equal to 3.0 t I caret plus 2.0 t square j caret plus 5.0 k caret, where t is in seconds and the coefficient